Arjun, can you hear me?
Yeah, but there was a lot of reverb. I can't hear you anymore. I think you're muted.
Yeah, let's start, Arjun.
Okay, so I'm gonna be presenting today about everyday physics. So like in secondary school, you'll be doing a lot of physics involving equations and learning different formulae. And that's really useful in some ways. It's really good to learn the theory about everything. But today I just wanted to go through some practical applications of physics because I think that might be interesting to a lot of people. So today I want to go through a part of physics which I personally find really interesting. So I'm going to be going through mechanics. If you're looking to go towards engineering in the future or do robotics or Lego or anything like that, you'll probably find this interesting. So today, I want to go through how levers work, how gears work, the practical applications of both. So we're going to see how they're used in the real world. So everyday physics. And I want to have some time for questions at the end and also to discuss what you guys are interested in so that I know what to prepare for in future talks like this. So in mechanics, the goal is always you're trying to create a device that can accomplish a certain function. So what you want to do is minimize effort. So how do we define effort? Effort is the amount of energy you invest into a particular device in order to achieve a certain goal. And you want to keep that effort as low as possible, but at the same time, you want to achieve the goal you're trying to do. So in a car, the effort that you're putting in is burning the fuel, and the mechanical advantage that you're achieving from burning this fuel and all of the forces involved in a car is driving the car forward. So that's the mechanical advantage that you're gaining. Yeah, so that's on a slide, the measure of force amplification achieved using a tool. Essentially, it's the ratio of the force that we put into a machine compared to the force that we exert on the target object, which is essentially what I went through. So in context, if we look at this diagram, there are different mechanisms that we can use to maximize our mechanical advantage. And there's lots of simple machines that I'll go through later in my talk. But here, what I've drawn up on this diagram is essentially a very simple lever. And what you're trying to do is lift an object on the other side of the lever. And the effort that you're putting in is the 10 Newton force here. So the mechanical advantage is lifting up the object here. And this is a lever. And if we put a 10 Newton force on one side of the lever, we create a turning effect called a moment that leads to the other side of the lever also rising. So why am I going through this diagram? Well, we can change parts of a lever to maximize the mechanical advantage that we can gain from doing something. So if we change the place where we put our 10 Newton force on the lever, we can change the mechanical advantage, the amount of force that we get on our target object. When we're looking at levers, an important equation that you should learn is that moment, or the turning force, is equal to the force times the distance. So looking at the distance from the center of the lever, or the fulcrum, in both of these diagrams, if the distance is shorter, then we have a smaller turning force. So this is all interesting. I just quickly went through some theory, but how are we actually going to use this in everyday life? So a lot of objects, use levers, even objects that you might not have thought about using levers. So if you look at everything around you, I guarantee you, if you just look around your room, you could find 10 objects that use levers as a significant part of their design. So I just wrote down three, the first three that came to the top of my mind. So doors, garlic presses, and scissors. And all of these fundamentally rely on levers. But let's look at some of these devices in more detail. So this is, I'm not sure if you've seen floor plans before, but this is the floor plan of a door. And you can see I've drawn 3 arrows, and these arrows represent points on which I can apply a force onto. And you can try this right now or after this talk's finished. Go up to your door and try pushing your door from different points along it. And you'll notice that if you try pushing your door from the very edge, I'm not sure how I can show it, but the top arrow, if you try pushing your door from this position, it's going to be really easy. Like that's why the handle of the door is at the edge of the door. But if you move your hand closer and closer to the middle of the door, you find that it gets increasingly harder to push the door. And if you go right to the edge, right next to the hinge, make sure that you don't get your fingers trapped. You'll find it a lot more difficult to push the door closed or even open the door. Another place where you might not think levers are used is sports. So if you notice, you want to hit the golf ball as far away as possible. You want to exert as much force as you can on the golf ball so that it travels through the air and to the hole, the target, where you're trying to get it to. And the way that this is achieved is the golf club. The point at which you hit the golf ball with the golf club is very far away from where, from your shoulder, from where the force is being exerted. And as we saw from the equation, if you can increase the distance between the fulcrum or the center of the lever and the object that you want to apply your force upon, you can increase the mechanical advantage and increase the force applied on the target object. So I just want to pause here and ask, does anyone have any questions or any other devices that they might think of also using levers, so that we can discuss, like unmute or send a message in the chat? Okay, I'll move on. And as you can see from this image, I've talked about levers, which is one of the 6 simple machines. And these simple machines is essentially what makes up the components of all of the devices that we use every day. So if you think about a car has all of these different devices. It has a lever in the gear system, and it has a wheel and axle in order to efficiently move itself forward. Inclined planes are used for, you can't see a car climbing upstairs, but if you use an inclined plane, instead of lifting it, it can increase its height a lot easier. And next, I want to talk about gears. So gears are essentially a type of lever, and it's used to transmit rotational force from one place to another And you have to bear in mind that in all of these machines, the amount of energy that you get at one end will be equal to the amount of energy that you put in at the other end. So in all of this, we can't increase the amount of energy in our machine, but we can manipulate it so that it becomes more useful. This diagram shows us. So you're going to put a set amount of energy into your gear system, but depending on what you want to achieve, you can either create a gear system that maximizes speed, or you can create a gear system that maximizes torque. But you might not have heard of this word before, but what is torque? Torque is very related to moments in that it's a measure of the turning force of a gear or a system. So I'll show it to you in this diagram. In any gear chain, you're going to have a driven gear and a driving gear. So you're going to be using energy to rotate one of those gears, and that gear will rotate the other gear. And you're probably going to have more gears to manipulate the rotations in different ways. So the larger gears will be rotating slower than the smaller gears because there's more teeth in the larger gear and there's less teeth in the smaller gear. So every time you go through 12 teeth, every time you go through 24 teeth on the big gear, you can go through on the small gear 2 sets of 12 teeth. So for every rotation on one gear, you can go through 2 rotations on another gear. And if you think about it, you're increasing the speed at which one of the gears rotates. But you can also do this the other way around. So if you have the driven gear on this side and the driving gear on this side, this gear rotates twice as fast as this gear. So you're essentially slowing down the rotation. So why would you want to slow down the rotation? It's because this larger gear has more torque, as we see in this diagram. And this means that it can, each of these teeth, the rotation applies more force on whatever you are trying to apply force upon. So this will make more sense in context, which is why I like to discuss physics in context, because I think it's more useful and makes more sense that way. So you've probably seen on a manual car at least, the gear and how you start off going in first gear, and then you can go up as you're going on the motorway, you go second gear, third gear, fourth gear, fifth gear, or reverse gear if you're trying to go backwards. And you probably heard about in physics that when you're trying to go up a hill, you need to apply force on the ground to accelerate. When you're starting your car, you need to accelerate to go faster. And in order to accelerate, you have to apply a force on an object to accelerate. So when you're starting up, you want to apply maximum force. And if we go back to the diagram, in order to maximize force, we want to get as much torque as possible, but that means that we're going to go slower. Here we see the car is climbing a hill and it has to go in first gear because it has to apply as much force as possible on the road. And this allows it to climb up the hill, but we have to make the trade-off because you can't just create energy. You have to sacrifice somewhere. And this means that the car will be going slower as it's starting up or going up a hill because it wants to apply as much force as possible. On the other hand, if you're going on the motorway at 60 miles an hour, you're already going fast and you don't want to accelerate your car. So you don't want to apply as much force on the ground. All you need to do is apply a force that acts against air resistance and friction so that you can maintain your speed. In that case, you don't need to have as much torque as you originally did. So you can sacrifice torque and get more speed. This is why the rotations per minute of a car you can keep relatively constant, but by changing the gear, you can change the speed and you can gain a mechanical advantage because you're making it easier to do the thing that you want to do. So to go through everything, this is, although I like to think of stuff in practice, there are some equations that you'll probably need to learn as if you're doing physics for GCSE in this topic. So moment equals force times distance. We saw that earlier in the slide where the output force here is greater than the output force here because the distance is greater. So even though the force is the same, the output force can be increased. I'm conscious that I am going pretty quickly, so I do want to stop once again to check if anybody has any questions. Okay, I'm gonna continue. So in context, again, I personally can't drive a car because I'm not old enough. So the bicycle analogy also makes a lot of sense to me. When you're starting on your journey on a bike, you're going to be going on gear 1 or gear 2 because it's very difficult at the beginning. You just want to get started. But once you're up to speed, you don't need to put as much effort accelerating. So you trade off the torque for speed as you go up into larger gears. And that increases your mechanical advantage because your goal no longer is to accelerate, but simply maintain the speed that you're going at. If the same amount of energy is put into a system, speed is inversely proportional to torque, i.e., a gear ratio that results in faster rotation will have less turning force. That's essentially what I showed in this diagram here. So where is this used? This is used in several different places. So engineering, if you want to do something in robotics or mechanical engineering or any type of engineering, or if you wanted to make clocks use gear trains quite a lot to manipulate speeds. You're going to want to make sure you have a firm grasp on the simple machines, because as your goal as an engineer is to make it as easy as possible and efficient as possible to achieve a certain outcome. You're probably going to be using all 6 of these simple machines. Architecture. So if you want to be designing bridges, there's a lot of discussion and a lot of thought that needs to be put into turning forces. So for example, in a cantilever bridge, at these points of stress, there's going to be lots of different forces acting on these points of stress. So you want to investigate whether it's going to be the force is going to be directly downwards, is the force going to be to the side, and often the force is going to be a turning force that can especially stress some materials, but put less stress on other materials. And also product design, like if you look around your desk, my stapler would use a lever, my desk lamp uses a lever, my door uses a lever. All of these products, you need to take into account different stresses and different forces that are going to be applied on them. And to do that, you have to have a firm grasp of mechanics, forces, and levers, and other simple machines. So I wanted to leave quite a lot of time for questions. And also I wanted to ask everybody, I'm going to be doing this again in the future, hopefully. So today I picked a topic in physics that I personally found interesting, but I really wanted to hear about what kind of topics you guys want to learn about in the future so that I can prepare appropriately. So please unmute or send a message in the chat.
Thank you, Arjun. Thank you, Arjun, for the lovely session. Really helpful, and I hope all the people who have joined in today, they enjoyed it. So I would encourage everybody to use chat and write the topics that you would want to hear next time from Arjun, and he would be happy to help you with any specific topic that you have in mind.
Hi Arjun, I would be interested in learning about space from you.
Okay, I'll do that next week.
Okay, thank you very much.
Thank you.
All right. There's something that has come up from Dhruv. He wants to know about nuclear energy. Arjun, is that something you would be comfortable with?
Yeah, that's a really interesting topic, actually. I'd want to talk about that in the future.
All right. Thank you, Dhruv. Thank you, Arjun. Risha, anything from you?
No, I really liked the session. I don't really know any other topics. I can't think of any.
Okay, that's fine. Thanks, Risha. Any questions, anybody from today's session? Come on, you guys should be asking a few questions. Looks like, Arjun, you have pretty much covered everything, and this is a recorded session. So we will be uploading this session on our YouTube channel. So if any one of you wants to revisit and or wants to share with your friends, please feel free to do so. But yeah, it was a lovely session. Thank you so much, Arjun. And we look forward to our next session.
Thank you.
The next session is tomorrow by Arjun Badra. So yeah, just look out for that.
Thank you so much, Arjun. Great talk.
Thank you for coming.
Yep, and we have a lovely session tomorrow from Arjun Badra, and he is talking about essay writing skills.
Wait, it's actually Arjun Kinge tomorrow.
Oh, that's Arjun Kinge. All right, okay, my bad.
Yeah, he's going to be talking about he's going to be doing a philosophy talk tomorrow about the just war theory. So that should be quite interesting. So yeah, he's going to be talking about conflict and stuff. So.
Lovely. So guys, if it's convenient, please do join in, and also let your other friends know about these sessions. Excellent. Any question from anyone? All right, looks like there are no more questions coming up, Arjun. So that's great. Thank you so much, Arjun. And thank you everyone for attending the session today.
Thank you for having me.
It's a pleasure, Arjun. Thank you. Thank you, everyone. See you all tomorrow.